Welcome everyone to CFT 2025. And this is Kirti Apte and my colleague Corby Page. And we are from VMware by Broadcom. And today our topic is Cloud Foundry as an agentic platform. So, as all of you know, there is a lot of excitement around AI. And you know, just one question for everybody. How many of you have AI use cases going on in your company, some shape or the form? Yeah, many hands there. So there is a lot of excitement around AI. AI landscape is evolving rapidly. But at the same time, when we talk to our Cloud Foundry customers, where are the biggest opportunities, right? That's the question. Even though companies are investing a lot into foundation models and the AI foundational stack, which is GPUs and GPU accelerators. But when we ask where are the biggest opportunities, there is always, applications need to generate more revenue in order to afford the technology stack underneath it. And that's where there are lots of patterns that we saw in the application space, starting from monolith to distributed applications to microservices based applications. And now the new emerging pattern into that space is the agents and the agentic apps. And that's where, there are many applications for these agents and there are many use cases for these agents. For example, starting with a simple one, providing natural language interface to your existing IT systems, for example. Or it may be as complex as having this business automation inside your company where business process agents are, working, as well as DevOps agents, code generation use cases that are evolving as well. Also, healthcare. Let's say, for example, I want to have monitor patients' vitals. There are agents for that, and then decide treatment based on that. So these are the use cases that are evolving, customer based and customer support use cases and customer care use cases, where I have summarization and entity extraction. So these are some of the use cases which are enterprise grade level that are emerging. And almost the year of 2025 is the year of agents. Now let's move forward and let's take a step back and try to understand the AI stack. And if you double click on the foundation models, or the large language models, right? So the foundation models, they are trained on massive amount of data, which is unlabeled or unstructured. But at the same time, they are, foundation models are improving, they are getting better. They have, responsive capabilities as well, and the reasoning capability. But at the same time, there are limitations with these foundation models, such as these foundation models. How do you make sure that these models can be trusted? Are they, but also the accuracy of the models depends on, even though they are trained on large amount of data, the quality of the data that they are trained on. There are biases, there are hallucinations in the model output, as well as what you see is these models, they have, country specific models. That scenario is evolving as well. So for example, Mistral is trained onto, European, it's a European model. Also, DeepSeek is Chinese model. So there is country specific, part to this foundation models as well. So to overcome this limitation, this AI stack, we have introduced the new layer into this AI stack, which is agentic orchestration layer. and that sits in between the foundation models and the integration layer. So what are these agents, right? So this is the simplest definition that I found about the agents, which is these are block of codes that have reasoning capability, right? That's a simple definition, and they are trained on a specific task. And I told you the specific task can be business process automation, DevOps agents, or healthcare agents, things like that. And the brain behind these agents is the LLMs, or the large language models. They also have access to long-term memory, or the RAG. So think of it as providing the fresh data to LLM. So for example, your company specific data or the domain data, such as financial data, for example, or you have your CRM data, Salesforce data, or any knowledge base that you have inside your company, which is, let's say, for example, user manuals. Typically, these are vectorized with the embedding models and then stored into the vector databases or the graph databases. And that's how these agents have access to this RAG, or the long-term memory. Also, they have access to short-term memory. So for example, content retention, then history of the what the conversation you are doing, you have to retain the history of that. So for adaptability, they have access to this short-term memory as well. And it's almost like a data flywheel, where it's constantly going through the loop, for each loop of reasoning, and then reasoning in and finding the right output after going through this entire for each loop. And that's how user has imperatives, it comes up with the reasoning, and the model output is many times accurate. And also this that what agent do, and this data flywheel is going on, as I told you earlier, inside the for each loop. So these are particularly the agents are, right? So now let's try to understand from this agentic apps perspective, putting together enterprise grade or the production grade agentic apps is complex. Like, as I told you earlier, there are a lot of integration points for this. So that's where Cloud Foundry as a platform comes into picture, where it's going to give it enterprise grade capabilities for these agentic apps, such as day two operations, as well as security, governance for your models. And that's where we have put together this architecture pattern using Cloud Foundry to build, deploy, manage these agentic apps. And the idea is very simple, right? So typically developers, they build AI enabled apps using their language of choice. It can be Java, Python, Spring AI, Spring Boot, and they deploy it onto Cloud Foundry platform with the CF push experience that Cloud Foundry users are familiar with. And then these apps, they can connect to the different Gen AI services, such as agentic apps that are deployed on the platform. And they can do this with the simple service broker interface that I have shown here. And we are going to see this in a demo as well. These agents, in turn, needs to connect to different Gen AI services. Like I talked about earlier, there are lots of integration points for these agents. So these agents need to connect to large language models, for example. So again, they can do this with the broker interface as well. They need to connect to data services or external data, internal data. They can again do that with the simple service broker interface. And this, when we are thinking about the large language models, enterprises, they have pre-approved or pre-vetted models that they want to use for their enterprise use cases. And Cloud Foundry platform, so the AI engineers or data scientists, they can deploy these models, which are pre-approved, onto the platform, and then connect it with the unified API interface, and also rate limiting access control. These are the security layer or the compliance governance which are required for the enterprise grade applications that are provided out of the box with the platform as well as day two operations, for example, observability, as well as the scalability, upgradability. These are the day two operations things that are provided by this Cloud Foundry platform as well. So platform engineers, they can, focus on putting together ETL pipelines, for example, or they can focus on building RAG pipelines or the DevOps pipelines instead of wondering about or worrying about the underlying infrastructure. And developers, they don't have to do any custom integrations to connect these different apps together. We are doing this with a simple service broker interface. And we are going to see that in action as well. And Corby is going to do that hardest part of showing that in action. But before I hand it over to Corby, just wanted to, touch base upon one of the important concept here, which is model context protocol. So I talked about all the agents and how they interact with this different complex systems, LLMs. But how do you standardize this communication between the agents? How do you have interoperability between this agent communication and the complex systems that these agents communicate with? And that's where model context protocol comes into picture, which is developed by Anthropic. And also Spring AI has have created support for this model context protocol as well. So the idea is simple. Think of it as a SAML protocol, for example, where email clients can communicate with each other in a standardized fashion. Similarly, model context protocol, you can deploy various model context protocol based agentic servers, and many clients, such as, let's say, chat client or any desktop Claude client, can connect to this deployed tools or the deployed servers. So you standardize the communication and interoperability is achieved as well. So this is about the model context protocol, and we are going to see this in action now. And that's the hardest part, like I said. So Corby, back to you.
Thank you. Awesome architecture. And then as Cloud Foundry devs, we want to say, how do we turn this into running applications? And I love Kirti's slide here because absolutely, it's hard. I have to type, unfortunately, while I'm talking here. See what to do. So what this diagram shows is on the left is that tiny little piece that, as a dev, that I'm responsible for, is that AI-enabled app. Everything else here, which is going to be required in order to be able to implement these GenAI applications, is being managed by the platform. And of course, our heroes, the platform operators. And so this takes a lot of context off of our plate here. So let's take a look here. We have an application on the right. This is a Spring Boot application. Thank you. Thank you very much. My application on the right is Tanzu Platform Chat. It's a Spring Boot application that has been pushed to the Cloud Foundry platform. And I can go ahead and use it to have a conversation, say, tell me about Cloud Foundry. And it's not going to be able to do a whole bunch because it doesn't have access to a chat model. So that's what the platform is going to provide here. And of course, the service binding construct of Cloud Foundry is the perfect model for this. I'm using the Tanzu GenAI tile, which allows me to safely provision access to approved models here. And so I'm just going to bind my application to it and restart. And this solves a lot of problems because now I'm not having to begin the very beginning of the process of talking to my company about what models are approved for use here. What are the rate limits? Can I get access to the GPU resources on-prem? You know, this sort of thing. These are obstacles that are early killers to productivity in terms of getting stuff up. I found it, ding. If you look in the upper right, we are now connected to a ChatGPT model, and I can go ahead and run my query again and say, tell me about Cloud Foundry. And we're off to the races now. So we're beginning to, we're getting closer to be able to deploy these Agentic AI apps that Kirti's been talking about. The next thing we're going to want to be able to do is be able to talk to documents. And in order to do that, we're going to have to use the RAG model. Here's our response on the Cloud Foundry. And if I take a look over here, what is required by a RAG model? Well, we're going to need a vector store, and we're going to need an embedding model. Why is that? Well, the way that RAG works is that when I want to index a document or data source to be able to query, then that document is going to get run through an embedding model. It's going to create a semantic index of the model, and it's going to store it into the what's called a vector database, which is optimized for being able to store these embeddings. And then when I come on in and run a query, then we're going to run that query through the embedding model as well to index it, and that allows us to perform what's called a similarity search in order to say, hey, what parts of the index document are relevant to the query that I just asked? And then we can find those relevant parts, upload those up to the LLM, and be able to run the chat requests. This is very important because we do not have the resources from a computer call standpoint to upload the entire document every time in order to run a query. So this RAG model that Kirti described allows us to find just the most relevant parts and upload it there. It's a great model, but it's infrastructure heavy. So that's where Cloud Foundry is super helpful here. Let's go on in and take our chat application. We're going to bind it to a vector database. And in this case, the vector database is a Cloud Foundry managed PostgreSQL instance. And we're going to bind it to an embeddings model that was provided by the chat tile here. And then I'll go ahead and restart the application. So once again, we have a situation where there's a lot of infrastructure needs in order to be able to run this scenario. But because the platform operator has set this up in a self-service model, and Cloud Foundry is very conducive to providing safe access to these resources, as a developer, in just a couple of minutes, I'm able to get up things running, and I'm going to have all the tooling here to be able to run it. So now I'm connected. You can see my application to the vector store and the embedding model. I'm going to take a PDF document and upload it. I'm uploading a Spring Health Assessment Report. It's a scan of dependencies in my Spring application. And I'm going to ask, what are my security vulnerabilities? So obviously with the straight up LLM model, it would have no way of answering this, but with RAG now, it can actually query my document and be able to find out the correct answer from there, but provide a natural language interface. And indeed, it gives me the vulnerabilities here. So let's go and move on to the big new stuff here. Let's say I ask it, what is the current price of Bitcoin? And it's going to tell me I have no idea. LLMs can't answer that. The models were built months ago. RAG can't answer that because it is using data that's only current as of the last time we indexed data. Now we need to start talking to live running software systems. And we also want to be able to control these systems through a natural language interface. So that's where the agentic model comes on in here. So Kirti, you developed for me a Spring Boot application that provides an API that gives me the current price of Bitcoin. We've pushed it to Cloud Foundry, and you put a thin MCP layer on top of that, which provides that pluggable interface so that my model can talk to it, and we get the agentic AI here. So I'm going to go ahead and bind my application to Kirti's Bitcoin server, and I'll go ahead and restart the application. And if I look over here, right now I don't have any agents bound yet, but it's going to hook up. And this MCP interface, we don't have time to go deep into it today, but it's really, really wonderful in terms of the plug and play capabilities here. That Kirti's model doesn't have to directly communicate with LLMs. It's a very lightweight API wrapper. It only needs to be able to provide a mechanism so that my application can figure out how to enlist it in an LLM conversation. So now you can see I'm bound to the Bitcoin server. And of course, Cloud Foundry is an ideal platform for doing these types of bindings. I can ask what is the current price of Bitcoin. And now it's going to figure out how to talk to Kirti's app and be able to invoke the right methods in order to answer the question. How easy is it for you, this is the important question, to take your existing applications and turn them into MCP agents and get things up and running? Well, I ran a quick experiment here. I took an application which was not built for this purpose. It was just a silly demo app that shows a sample factory, auto management factory dashboard here. It has different manufacturing stages. It lets me look at the view of IoT devices. It lets me see what the status of the supply chain is on here and stuff like that. So I just took the application as is. CF pushed it to Cloud Foundry. Then and this was a Spring app, and went down to customer, by the way, and did all this stuff with last week with .NET and Python as well, and Node. So this is a polyglot, but I love working with Spring AI because it's so cool. And so I just took the application, I pulled in the Spring AI MCP client libraries into my pom.xml, and then on each of my methods that I wanted to expose, I put a little tool annotation. It was just a natural language description of what the method is and what the parameters are. That's enough context for the LLM to understand how to interact and use the application. Other than that, I did not touch one line of existing code in this running application. I took it as it is, CF pushed it to the application. Now let's go ahead and bind the service to the piece here. So this is going to be our factory MCP server, and then we'll go ahead and deploy. And so now it's taking those MCP endpoints, providing connectivity to that in my application. We'll get the agents up, so it's restarting. And we're up. So now we're talking to both the Bitcoin server and the factory MCP server, and that's how simple it is. I can ask it questions, and now you have a conversational interface with your application. You can talk to it, you can make friends with it, and who knows, you may find love. So here we are. We got the application going up and running, and we're good to go. So, what is the friction? What is the throttle, the choke point in terms of getting this stuff out? It's not ideas. I know that everybody who's watching this today has ideas when they look at this and say, oh, I know what I could do with my applications in terms of making them AI-enabled, cool things I could do, cool value. Hey, I went in and created this guy, CF Pulse. This is a natural language interface to be able to control my Cloud Foundry foundation, and I use that as my daily driver. It goes on in and is a real nice shortcut for being able to work with this system there. So everybody's got ideas. The obstacle is always going to be on the infrastructure side, on the deployment side, on getting things approval through corporate in terms of being able to get the developers up and running, because you want those fast iterations, get things in front of your boss, getting things out in front of the customer, and Cloud Foundry is the ideal platform to be able to do this.